liquid application control simulation for a variable rate application sprayer. This is our final year project demo, and this is me, Mohammad Faizan, and our project supervisor is Dr. Mutofir Khan. Going through the basics of the sprayer. So, as we know, Pakistan is an agriculture country. For the growth of the agriculture, uh, we need precision farming technology. As we know that the variable rate application sprayer is used to spray pesticide at desired rate. Objective of our project is minimize pressure fluctuation. The liquid application spray maintains suitable spray angle, minimize droplet size, and developing an environmentally friendly sprayer. Apply desired pesticides application at constant pressure. This is a problem we are trying to solve. Spray pressure fluctuates during the liquid application, which could lead to the problem of drift, droplet size, and spray angle. These spray characteristics are not desired when spraying with the variable rate application. So in order to solve all those issues, we need to control and stabilize the pressure for precise liquid application. So here is the methodology for liquid control. We have controlled liquid by pulse width modulation, in which the solenoid valves are controlled through the through varying the on time of the solenoid valve, which is called the duty cycle. As the duty cycle is varied, the flow through the valve is also varied. Flow rate is also controlled using the pressure compensated flow control valve. In this technique, a closed loop mechanism is used. Reading from the flow sensor is compared with the desired value, then error is fed to the proportional controller, which is used to make correction. In the next, we control the pressure. Constant pressure is desired as to minimize drift and droplet size issues, which is also controlled in the closed loop mechanism, which takes feedback from the pressure sensor, compare with the desired value, and then if the error is positive, control will increase the motor speed. Else if the error is negative, then control will decrease the pump motor speed in order to reduce the error. Pressure fluctuation has been seen in the simulation when we were installing three pulse width modulation controlled solenoid valves at the boom section. So in order to uh, minimize those fluctuation, a pressure relief valve is used at the bypass line. So we will go through the MATLAB and see the simulation of the project. First, the pressure control simulations. So if I zoom this section, this is the plumbing of the spray, and pump is connected to the tank, and the main line bypass line is connected, and pump is powered by a velocity source. If I zoom this section on the left, and this section, let me zoom it again. This section, motor which drives the pump is controlled by PID, and we are taking the pressure sensor reading and comparing with the actual with the desired value, and the error signal is calculated, which is fed to the controller. Controller is controlling the motor speed to maintain the desired pressure in the system. If we go on the top, we can see that we are controlling flow rate by the pressure compensated flow control valve, and the flow rate sensor is used to measure the flow, and this reading is compared with the desired value, and the error signal is used as an input to the proportional flow controller, which control the valve. So if we run the simulation and see the results, So the pressure set point is 100 psi, and our actual pressure is reaching it in 1 second with the less overshoot. If we see the flow control, so this is the flow control performance is um, very good, and we can see that the flow rate is given in meter cube per second, and the yellow line is the desired flow and the blue line is actual flow. And if we show the PWM based technique to control flow, so if we zoom this, here we can see that we have given a different duty cycle to the PWM generator, which is connected by which is given a gain of 24 volt. And now if you check the signal, this signal is of 24 volt PWM signal. These are the two-way valves which are controlled by solenoid, and solenoid is powered by a 24 volt PWM signal. A flow sensor is connected to measure the flow rate, and plumbing as discussed earlier, and the pump control. So if we run the simulation, see the results. This block is used to export data to workspace, pressure data or flow data. So we also conversion unit are added, which convert pressure pascals to psi, and we see the results. Pressure, we see small fluctuations. There were large fluctuation, uh, but those fluctuations were reduced by setting pressure relief valve to appropriate value. Here is the flow of the solenoid valve. We can also see which is also a stable value. So if we go back to the presentation, these are the results we obtained from the laboratory. Flow control versus duty cycle, and here is the results we obtained for the 12 volt solenoid valve. Flow control simulations, as we have seen in simulation, and pressure control, and we have seen the small fluctuations. They were large, but we reduced it by using pressure relief valve. Conclusion from the simulation, it is concluded that spray pressure is stable and less overshoot. It has a less overshoot and settling time equal to 1. Flow rate value is also stable, so we minimize the pressure fluctuation in the system by the pressure relief valves. So thank you so much.